Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 2. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as an independent current source IS. Additionally, we can observe the presence of a dependent source, especially a current-controlled current source. The question now is to calculate the voltage values at the nodes. Let's move on to the solution. First, let's start by labeling all the nodes in the circuits. And I will consider this node as node 1, this node as node 2, and this node as node 3. After we will assign the voltages V1, V2, and V3 respectively to those 3 nodes. Next, you will need to select a reference node in the circuit. The reference node is typically chosen as the node with the most connection or as the ground node. And let's assign now arbitrarily the currents in each branch. And I will consider I1 is the current through the resistor R2, I2 is the current through the resistor R3, and I3 is the current through the resistor R4. Next, we'll proceed to apply Kirchhoff's current law in each node. Let's start first with node 1. By applying KCL at node 1, we can write IS is equal to IX plus I3. And if we replace IS with its numerical value, we obtain IX plus I3 is equal to 3. Let's move on now to node 2. By applying KCL at node 2, we can write IX is equal to I1 plus I2. And by applying KCL at node 3, we can write 2IX is equal to I2 plus I3. According to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be determined by the following equation. I1 is equal to V2 minus 0 over R2. I2 is equal to V2 minus V3 over R3. I3 is equal to V1 minus V3 over R4. And the last one, IX is equal to V1 minus V2 over R1. By substituting equation A and B in 1, we can write 3 is equal to V1 minus V2 over R1 plus V1 minus V3 over R4. And if we replace the resistors with their numerical values, we obtain 3 is equal to V1 minus V2 over 2 plus V1 minus V3 over 4. And if we continue simplifying this equation, we obtain 3V1 minus 2V2 minus V3 minus 12 is equal to 0. And by substituting now A, B, and D in 2, we can write V1 minus V2 over R1 is equal to V2 over R2 plus V2 minus V3 over R3. And if we replace the resistors with their numerical values, and if we continue simplifying this equation, we obtain finally 4V1 minus 7V2 plus V3 is equal to 0. And by substituting now B, C, and D in 3, we obtain 2V1 minus V2 over R1 is equal to V2 minus V3 over R3 plus V1 minus V3 over R4. And if we replace the resistor with their numerical values and we continue simplifying this equation, we obtain 6V1 minus 9V2 plus 3V3 is equal to 0. After we finish applying the nodal analysis, we obtain 3 equations with the 3 unknowns. By performing now equation 4 plus equation 5, we can write 7v1 minus 9v2 minus 12 is equal to 0. And from here, we can write v1 in terms of v2 is v1 is equal to 9v2 plus 12 over 7. And now by performing equation 6 minus 1.5 times equation 4, we obtain 1.5 v2 plus 1.5 v3 is equal to 0. And from here, we can obtain v3 is equal to negative v2. And by substituting a and b in 5, we derive one equation in terms of v2. And if we continue simplifying this equation, we obtain 48 minus 20v2 is equal to 0. That means v2 is equal to 48 over 20 is equal to 2.4 volt. Now from equation A, we have v1 is equal to 9v2 plus 12 over 7. If we replace v2 with its numerical value, we obtain v1 is equal to 33.6 over 7. We get v1 is equal to 4.8 volt. Let's move on to B. We know that v3 is equal to negative v2, and that means v3 is equal to negative 2.4 volt. And after completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here is the current, the independent current source IS, and the dependent source, a current controlled current source, resistor R1, R2, R3, and R4. We connect here voltmeter to measure the node voltage V1, and here a voltmeter to measure the node voltage V2, and here a voltmeter to measure the node voltage V3. Let's move on to analysis. DC analysis, calculate nodal voltages. We can see here that V1 is equal to 4.8 volt, V2 is equal to 2.4 volt, and V3 is equal to negative 2.4 volt. Up on completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video. Take care and bye bye.